So continuing on, the second macromolecule we're going to talk about are called lipids. So the main function of lipids is long-term energy storage. So it's kind of the opposite of carbohydrates. Some other uses in the body are for cushioning organs, insulation. So insulation just has to do with maintaining our body temperature. So if you think about I'll just leave it at that, okay? You're just insulating yourself. The more cells, the more lipids, the more fat cells that you have, the warmer and more insulated your body and your organs are gonna be, okay? And so some other uses, so lipids can also form hormones. There are actually two types of hormones which are used for cell signaling. There are steroid hormones and there are peptide hormones, but we won't be getting into that in this class. But yeah, so lipids and fats can actually be used in cell signaling in the form of hormones. And then lipids do make up the cell membrane. They have a subgroup of lipids called phospholipids, and phospholipids are what make up the outer layer, the outer membrane of every single one of our cells. So they are super, super important in the body. Okay, and lipids are found in fats, oils, again, there's that word I just said, phospholipids in the cell membrane, and they're also found in steroids. And no, we are not talking about anabolic steroids, so the kind of stuff you want to ingest when you're trying to bulk up. Well, you don't want to do that, but some people do. But we're not talking about those kinds of steroids. Okay, and lipids are also made up of carbon, hydrogen, and oxygen, just like carbohydrates are. Okay, so lipids don't really have a true monomer. However, mostly they're made up of fatty acids. Okay, and lipids polymer, so these fatty acids link together and they form fats, oils, phospholipids, steroids, and hormones. So kind of like that list of uses that we were looking at before. So that's what those fatty acids build. Okay, and so when we look at energy storage for lipids, so for every milligram of fat we ingest, we are able to store 9 calories. So that's actually a little bit more than it was for carbs, but it's not as efficient. And we will, I'm sure, get into that a little, we'll go into that more in depth in a little bit, but not right now. But yeah, so we can actually store a little bit more energy when we store lipids. Okay, but anyway, so when your body runs out of carbs, it will then break down lipids to get energy. So first it'll use up all your stored carbohydrates, then it'll attack your lipids, your fats. Okay, and this is just a little bit more on phospholipids. So a phospholipid is a special type of lipid. And phospholipids, their structure, they're made up of 2 fatty acids. So remember, that's the monomer of a lipid. They're also made up of a phosphate and a glycerol molecule. Okay, you don't really need to think too hard about what I'm talking about in here, but just kind of start getting used to using these words. So phospholipids are made up of 2 fatty acids, a phosphate, and a glycerol molecule. And like I said, these molecules are found making up the plasma membrane of cells. And the phosphate group is hydrophilic, while the fatty acid area is hydrophobic. If we remember that from the previous concepts, let's kind of pull this over here. So right here, we're looking at a phospholipid. So here is the phosphate head. So that's what it's called, this little group right here. You can see phosphorus is here in the middle. It's called a phosphate. And right here is what we call a glycerol. And then on the edge here, we have a fatty acid tail, okay? And so this is what a phospholipid looks like, and this is what the plasma membrane in our cells look like. So we see that all the fatty acid tails are turned in on themselves, okay? And this is because when we want to think about what the environment of a cell is. Cells are very liquidy. They're water-based. So when something is water-based, are they polar or non-polar? If you said polar, great job. You've been studying. Okay, so the cellular environment is very polar, and so fatty acids are very hydrophobic. Fatty acids are nonpolar, they do not like water, they do not mix. So what happens when you have a bunch of phospholipids next to one another, what's going to happen is they're going to turn in to face each other to avoid having to interact with the water outside the cell and the water inside the cell. So they're all going to turn in away from that water. And so the phosphate group, so we see how there's a little bit of a charge here? So that charge, there's a little negative charge on that oxygen. That charge there creates a polar section of the phospholipid. So that polarized section, since it has a charge, is going to be very hydrophilic. It's going to be water loving. It's going to it's going to enjoy interacting with the watery, liquidy environment of the cell, whether it's inside or outside. So it's kind of a symbiotic relationship. They're basically doing each other a solid, and so they're both very happy. The fatty acid tails are away from the water, and the phosphate heads are towards the water. So everybody's happy.